Mm-hmm. Oh. Hello there. Looks like we've got Allison on the call and Maggie. Nice to see both of you. Recording, which is great. Do you have the link for this, Matt? Would you like it?
I don't have the link for it.
I will send it to you. Ooh. Mm. All right. Got a couple Allison Lombachers in now. We've got Janice. Good to see you, Janice, or good to know you're here anyway. Your camera's off, which is fine. Hello, hi Maggie. Where are you videoing in from, Maggie?
I'm in Virginia.
Okay, awesome.
In, Newport News Public Schools.
Gotcha. So do you already have hummingbirds at your school?
We do. We've got, we're part of a CyberSteam grant at the middle school that I'm at. And we are, I've got one and we're supposed to be getting a whole bunch more.
Great. Awesome. That's awesome. Well, we are going to take a look at all the different capabilities of Hummingbird tonight. We're also, we were kind of specifically targeting some teachers in Iowa as well. You are absolutely welcome, and you will find many useful things in today's webinar. But you're going to hear us talk about the Iowa STEM Scale Up Grant and some of the tools that they got. So they got this big like cabinet full of maker tools. And so we're going to be talking about the Hummingbird and a couple other things that came in that and how they can work together. But those tools, specifically the Make Do kit and the 3 Ducks connectors, those are things that you can certainly purchase as well. You don't need to use them with your Hummingbird, but we're going to be talking about how Hummingbird works with those things as well. So just so you know.
I'm going to get my notepad. Do you want us to keep our cameras open the whole time?
You can if you want. And when you're not speaking, if you can mute it. But if you want to keep your camera open, it's nice for me because then I don't feel like I'm talking to myself. So
okay.
That's awesome. Thanks. It's nice to meet you, Maggie.
Thank you.
Well, it looks like we got Susan here. Good to have you, Susan. I'm glad you're here. I'm going to start dropping a link into the, that's not the link. That's inviting you to a Zoom chat you're already in. Need to get a different link. There we go. So the link that I'm going to drop in there now is to a Google Doc where we're going to have all kinds of resources on there. So one that says Google Doc, the sort of second hyperlink down there. You can certainly, let's see. There we go. Great. Hello. Hey, Jolie. How's it going? I'm going to unmute you. Oh, let me try. Let's see if you are unmuted, Jolie.
Yes.
Yes. Excellent.
I think I tried to unmute at the same time you tried to unmute. So I think that's what happened.
I think you're right. I think that is exactly what happened. Well, that's great. I'm so glad that you're here. Your background looks really cool. Are you calling from the Science Center?
I am. I'm in our new innovation lab that we opened this spring. And it's an awesome, exciting place for creating and trying new things. And we have preschoolers that come in here and homeschool students and teachers and lots of opportunity in here.
That's awesome. It looks like a really, really cool space. That's great. Well, we'll kind of hang out for a little bit longer while people join us. And as people do join us, I'm going to continue to just like keep reposting this Google Doc as a link in the group chat. And so everybody can open up that Google Doc. We're going to all kind of be working on that and seeing it together. So the first thing in the Google Doc is actually to sign in. So if you want to sign in on that that where it says sign in here. If you click on there, that'll take you to a little form, just so we know who signed, we know who signed up for the webinar, but that way we know who actually joined. So you can see how many people were actually here. Looks like we've got Beth joining us as well. Hello, Beth, welcome. Susan, thanks for putting your camera on. It makes me feel like I'm not alone in a room. I appreciate you. And also, if anybody wants to, I know we have one person joining us from Virginia, but I'd love to hear your city and state that you're joining us from. My thinking is that most people will be from Iowa, are going to be scattered around Iowa. But if in the Google chat, or in the Zoom chat, excuse me, you want to put the city and state that you're joining us from, it would be good to see where people are coming from. So I'm going to put Pittsburgh, PA, because I'm in a basement in Pittsburgh, PA. Looks like we've got Esterville. Nice. Very good. I'm actually, so I live in Pittsburgh now, but I'm from Iowa originally. I'm from West Des Moines. I'm a Valley grad and a University of Northern Iowa Panther grad as well. So I know where some little towns are in Iowa. Don't know where they all are, I'll say. Looks like we got Jennifer joining us. Glad you're here, Jennifer. Hey, Sarah Emmerich's here. Hey, oh, hello. I'm so glad to see you. Hooray. We've got some Alton, Iowa people, Pocahontas. Matt Chilbert, by the way, he is the beardy fellow with a hat on. He is in the same room as me, just in a different part of it. Great. So if you're just joining us, if you're just tuning in, if you want to put your city and state that you're joining us from in the chat window of our Zoom video chat, it's good to know where people are joining us from. And then I'll also drop a Google Doc link in there. And Matt will continue to kind of drop that every few minutes or so, just so that anybody just joining us, they only see the chats from the time they joined on. So when you join the chat, hopefully that Google Doc link will be up there for you, and you can access the Google Doc. So let me show you that Google Doc right now. This is probably what you're looking at. STEM Scale Up and the Hummingbird Bit. And then we've got a little agenda there. And see right here where it says Icebreaker and it says sign in here. If you can click on that, that'll take you to a little form, and that just helps us know who actually attended the webinar. We know who signed up, but that lets us know who actually attended. So if you just click on it where it says here, that'll take you to a form where you can sign in, and that way we can count you present. Not that there are points awarded for that, but we are glad you're here, very much so. We've got Newport News, Virginia. That is very close to, yeah, Williamsburg. I have some family out there in like Virginia Beach area, so hopefully you guys have a little warmer weather than we do. Sarah's coming from Waukee. What's up? What's up? This is great. Well, while we're getting all signed into that Google Doc and starting to meet each other, or starting to all get signed in here, I'll introduce myself and then I'll have Jolie introduce herself. So my name is Kelsey Derringer. I am the Professional Development Coordinator for BirdBrain Technologies. So that means that I travel around the country and I teach teachers how to do coding and robotics in their classrooms with both the Hummingbird Kit and the Finch. The Finch is this little white guy up on the shelves back here. And I also work with all kinds of different organizations, from individual teachers to schools to districts to huge service organizations like the Iowa Science Center, who services the entire state of Iowa with the Iowa STEM Scale Up Grant cabinets. And so I'll let Jolie introduce herself and talk a little bit about kind of how she's interacted with Hummingbird as well.
So, hello. Many of you I've seen recently at trainings over the summer and our webinar series for the Making STEM Connections program. But my name is Jolie Pelds, and I'm the Director of Innovative STEM Teaching at the Science Center of Iowa. And I get the great, incredible pleasure of working with educators, formal and informal, all over the state. And one of the programs that we work with is based on putting a makerspace in an educational setting. And the Hummingbird materials are one of the components of the kits that teachers receive through the Scale Up funding from the Iowa Governor STEM Advisory Council. So I have been utilizing the Hummingbird materials for the last 4 years with educators. And we're really excited to have Kelsey talk with us today and to give us some more insight on the newest version that has the Hummingbird incorporating the Microbit and all the new amazing things that it can do.
Great. Well, thank you so much, Jolie. It was really nice to meet you a couple years ago when I came back to Iowa, and we first met then. And it's pretty remarkable. All across Iowa, teachers have these giant cabinets full of maker tools, and one of the tools in there, alongside drill bits and sewing machines and all kinds of cool maker tools, is the Hummingbird. And Jolie does an amazing training when when these teachers first get the kit. She has a whole day with them, but in that whole day, you've got to introduce the concept of maker education and like some big concepts and how to use all the different tools that are in there. It's a really big job. So I'm really glad that we just invented this studio in the basement of BirdBrain Technologies. We call it our live stream learning studio, so that we can access teachers and meet teachers where they are a little bit better with this awesome webinar setup. And it's got some really cool capabilities that you'll see as we go along too. But I'd love to start us off with a little icebreaker. The second little thing in the icebreaker says to go to menti.com. And if you want to go to menti.com, I'll switch my screen over there and just enter in those 3 numbers. That will open up. And actually, if you're not speaking at the moment, if you can mute your microphone, that would be great. But let's see who is unmuted.
All right, see.
Go back over here.
Me too. Bye.
Okay, so, but if you can just enter in, why do you think that we should be teaching coding and robotics? What are some reasons, your top 2 reasons for why you think that we should be teaching this? And I'd love to see what everybody's coming in with. And we'll see everybody's answers come in live. So if you go either on your phone or on your computer, if you've got one, if you go to menti.com and type in those 3 numbers, then this question will appear for you and you can answer it. So it looks like we have a couple of people who are interested in the competencies model, 21st century skills, persistence, grit, things like that. Yeah. And got a couple of people interested in economic and workforce development, so like preparing students for future jobs. A couple people interested in equity and innovation, sociological, social, scientific innovation. There's a bunch of different options on there too. I think sometimes the things that teachers can be interested in, like the conversations that are going on, are often kind of regional conversations too. So maybe in Iowa, there's a big conversation happening around 21st century skills, and maybe in, say, Virginia, there are more conversations happening around innovation or things like that. Be interesting to know. Ooh, we got a new one in the mix: school reform and improvement. So changing how we do school. So we think there's one person that thinks that teaching coding and robotics can like fundamentally change how we do school. I think that's an interesting topic as well. Looks like our 2 popular ones are innovation and then those competencies and literacies. And you can continue to add to this throughout the webinar as well. But I think that there are lots of different reasons that you could choose to, oops, let me do this one. There are a lot of different reasons why you could choose to teach robotics. There are a lot of really good reasons why you could choose to teach robotics. And for me, when I was first teaching robotics, a little bit about my background, I'm a certified middle school and high school English teacher, but I taught this after school girls only STEM club for 4th through 8th grade students, girls only. And for me, the reason I wanted to teach robotics is that it centered around this question of equity. I wanted my girls to have the same access to the technology tools that kids in other districts and kids in other schools and the boys had access to. I wanted them to be able to get creative with coding. I wanted them to experience joy and be like, just like, oh, really on fire for making and, making all kinds of different things with coding. But it all centered around this topic of equity. I want to get more girls and students of color and rural students. I want to get them at the table at places like Facebook and Amazon and, those places that are really controlling a lot of our national and global conversations right now. So I'd love to kick it back over to Jolie and just maybe talk a little bit about that STEM Scale Up grant, which I put on our whiteboard back here. Aha. So if you could just give us a little bit of background about what that STEM Scale Up grant is and how teachers got or can get access to it if they're in the state of Iowa. Just a couple minutes about that.
Sure. So the Iowa Governor's STEM Advisory Council is able to take legislative funds that are appropriated to them and support STEM education all across the state. And one of the ways they do that is called the Scale Up program. And the idea is to take programs and scale them up so that educators, whether they're in a small town or big town, whether they're in a formal school and after school setting, could support STEM learning. And so each year the Governor's Council selects a number of programs on a national level. They have a pool to select from. And the Science Center has been selected for the last 6 years to participate in this program. And the last 4 specifically, we have been able to support teachers with a program called Making STEM Connections. So teachers that are interested in this program, it can be directly purchased from the Science Center. We developed the program and all the materials that come in the kit, but you can apply to receive it through the Scale Up grant through the Iowa Governor's STEM Advisory Council. So the application process opens in January, and it is available to only Iowa educators, but it can be pre-K through 12, through grade 12, and as long as you're working directly with students, that's what the application process is for. So then the Governor's Council makes all the selections, and then they tell us at the Science Center, here are the people that are awarded, and then we get the fabulous opportunity to work with them. So in the last 4 years, we have distributed probably 400, almost 500 kits of STEM materials across the state and have worked with over 1,000 teachers. And the concept of putting a makerspace in an educational setting.
That is truly amazing, like the impact that you're able to have with that program. And I think this is a huge argument for why different programs should be supported at the state level with both funding and professional development and resources like physical tools and resources. So while we're, nice transition I just set myself up for, let's talk about some of those resources. So in that maker kit, that cabinet that you guys hand out, there's all kinds of different tools in there. And one of them is the Hummingbird Robotics Kit. And so some of you, even if you're not joining us from Iowa, you probably have a kit that looks like this. You may have the older version of the kit, which is called the Duo. We're going to be focusing on the newer version of the kit, which is the Bit. But I'll also make sure to tell you where to find more resources about your Duo on our website as well. So in your Hummingbird Bit Kit, when you open it up, it looks like this, which even though there are these nice little organized and labeled little compartments, which are pretty cool. This also still might kind of look like just a bunch of wires to you. I know it did to me when I was first introduced to robotics. My introduction, by the way, was I was handed a gallon-sized baggie of all of this stuff just mixed in there, and my administrator said, "You're doing robots next week," and I said, I can't do that. I'm an English teacher. And then I just taught myself using like the internet that first year. And I love code.org calls teachers lead learners. And that was certainly me that first year. So I think it's a great way to approach doing something new in your classroom. But okay, so how do we start understanding what all of this stuff is? I think it's nice to talk about what a robot is to start with. So a robot, just to break it down to its most essential bits, is something that senses, thinks, and acts. And so in your kit, you get a few different kinds of sensors. This one's a dial sensor, that one's a light sensor, here's a sound sensor, and this one's a distance sensor. So those are 4 different kinds of sensors that come in the Bit Kit. The thinking happens on the board itself, and I'll talk a little bit about these 2 different pieces here, but the thinking happens on the Microbit and the Hummingbird. And then the actions, well, those are LEDs or motors. Those are the kinds of actions that you can do. And actually, when I first heard this, I was like, oh, like I kind of wish it did more like lights and motors. What can you do with that? Well, what can you do with lights and motors? You can make anything because they're designed to be combined with craft supplies, you can hot glue right onto the motors and peel it off when you're done, put it back in the kit. You can poke holes in cardboard and put lights through them. You can use cardboard, popsicle sticks, pipe cleaners, bar napkins, whatever you've got nearby to make whatever you're interested in into a robot. So just to give you a little bit more of an overview of what the Hummingbird kit is and what the kind of essential parts of it are. So to start with your Hummingbird, you'll probably grab out your Hummingbird, you'll probably grab out the Microbit. It comes with a battery pack, which takes 4 AA batteries, and you'll probably need the USB cord that comes in there as well. And so just to kind of get everything started and to talk a little bit about these two pieces and why they're two separate pieces. So this right here is the Hummingbird. This is what BirdBrain makes. But this is called a Microbit. And so the Microbit is a super powerful little computer science tool. If you've ever heard of something like an Arduino, that's a type of microcontroller, just like a Microbit. Anything electronic probably has some kind of microcontroller in it. But the difference between a Microbit and something like an Arduino is that the Microbit was created for educators. So we don't actually make this. On the back, if you look at it, it actually says BBC on there. So the BBC Foundation makes this. We don't make it, we just use it. But it's got these little A and B buttons you can use as a form of input. This is a 5x5 LED screen display, so you can scroll letters across it. You can show symbols and things like that. Along the bottom here, these little gold things, these are ports where you could use an alligator clip and you could clip on LEDs or motors if you wanted to. There's 4 ports down there. And if you read all the little letters on the back, it's also got an accelerometer, so it knows when it's being tilted. It's got a compass, so it knows what direction it's pointing. And it's also got a radio in it. And this is not like a music radio, it's like a radio signal. So it can send and receive signals through the Microbit. It's a really, really cool, powerful computer science tool. This thing is $15. And it's got like at least a semester's worth of really high quality, hands-on physical computing, computer science curriculum that goes with it. Super powerful little tool. But if you want to get into the robotics side of it, it can be a little bit finicky. So if you want to attach lights and motors down here, you might have to use like alligator clips, which can tend to fall off. And if you want to use a nice like 5-volt motor like this, well, this is a 3-volt board and you have to use like a shield so that you don't blow out the board, and it just like very quickly becomes something that a 3rd grader can't really reasonably be asked to do. So what we did with the Hummingbird is you just snap your Microbit in there, and this becomes a breakout board for the Microbit now. So instead of 4 ports that are a little difficult to connect to, now you've got these 2 green ports here. Let me zoom in on here. Oh, I zoomed this way. I remember now. Still learning our new camera. There we go. Okay. So if I zoom in on that one, there we go. Matt's laughing because he just taught me this, but I'm still learning. But so we've got 2 tricolor ports here. 1, 2, those are for your 2 tricolor LEDs that come in the kit. 3 single color LED ports, those are the yellow ones. You can plug in 3 single LEDs. 4 motor ports along the side here, so you can plug in 4 motors at a time. And 3 sensor ports along the bottom. So those 4 sensors, you can plug in 3 of them down here. And then this is a buzzer. So you can actually also make it make noise with the buzzer. And so that's 13 different things that you can plug into the same brain or the same Microbit. So that makes this a really powerful little tool. And look how easy it is to connect a component to your Hummingbird. So this right here comes in your kit as well. This is called a terminal tool. I call it a poking stick because it's used for poking. So here's what you do with it. See on here it says port 1, 2, and 3. Here's port 1, and we've got positive and negative there. Well, this is an LED that I just pulled out here. This is going to be a green colored LED. And on the other end, it's got some wires poking out. So here's how easy it is to connect an LED. You push down the button, insert, I'm actually going to use my fingernail because I'm better at it. Push down the button, insert the wire at about a 45-degree angle. The black wire always goes in the negative port. And so now both of my wires are connected really securely. And when I'm ready to program it, this light will go on and off. And I can plug in 3 single color LEDs, 2 tricolor LEDs, all to the same Hummingbird. So I'm also going to plug in my battery pack here. like so. And I've actually already put my Hummingbird into Bluetooth mode. So it's flashing some letters on the screen here. It's flashing F, what is it? FSC. And that'll come into play later why it's flashing those 3 letters. So the way you put it into Bluetooth mode, I'm going to show you around our website so you can find how to do that. But I think one of the biggest strengths about the new Hummingbird, especially versus the old one, is that you can use this with whatever technology you have in your classroom. So whether you've got a laptop, a Chromebook, an iPad, a Kindle, a smartphone, whatever you have access to in your learning space, you can use a Hummingbird with that. So I'm going to show you the Hummingbird with an iPad, but you can also use it with, like I said, a laptop, Chromebook, whatever. But I'm going to show you it with an iPad. So I'm going to just give you a quick overview of what it's like to program with a Hummingbird. I'm going to zoom out just a skosh. There we go. Bring my Hummingbird into the frame here and put my LED in the frame as well so that you can see that when I start to blink it. Okay, cool. So let me turn my iPad on. And the app that you would use if you're on an iPad is called BirdBlocks. It's a free app. It's BirdBlocks. I'm gonna focus this up so Matt likes me again. There we go. Okay. Not that one. This one. Okay. So BirdBlocks, it's a free app. You can put it on your phone right now if you want to. Again, you don't have to use this app. You can use all kinds of different programming languages on different devices. But if I switch over to our Google Doc real quick, if you scroll down on the Google Doc, this Hummingbird Bit overview, I'm kind of going through these things right now. So if you want to see what it's like to program your Hummingbird with a Chromebook or a laptop, or you want to try doing that right now, go to the BirdBrain portal. I'm going to come back to that later, but go to that BirdBrain portal and just start clicking around and see what you find there, okay? So coming back to here, I'm going to connect to my Hummingbird. I'm going to do this wirelessly through Bluetooth. Remember that FSC that was popping up? Well, this says Floppy Sky Chicken. That's what FSC corresponds to. It corresponds to the name of your Hummingbird. So I'm going to connect to that. I don't know if you heard that noise, but that's the sound of success. We successfully connected to our Hummingbird. And now I'm just going to make this single color LED turn on. So first thing I'm going to do is I'm just going to set this LED block to 100, and I'm going to click it. Look at there, we just turned a light on. Oh, it's so easy to start doing robotics with this. Remember how easy it was to plug it in, easy to connect. Now we got our light turning on. I'm going to drag out a couple more blocks. I could turn it off by clicking the 0, 100, 0, 100, 0. I'm going to snap those together. I'm going to put them inside of this gold repeat forever loop. And now if I click that, watch that, it's going on, off, repeat, but that's going too fast. That's going to give me a conniption fit. So I'm going to make it wait 1 second in between each of these. So now it's going to go on for a second and off for a second. And I can, if you're familiar with Scratch as a programming language, I could put this when green flag tapped icon on top. And now when I tap the green flag, that will initiate my program. So I don't want to get too far into programming with it because we have all kinds of free tutorials to teach you how to do this. So let me show you. On our website here, if I go to the BirdBrain Learning Portal, that will open up something that looks like this. We tried to make it so that you could decide what you wanted to do with this, because so many teachers have so many different devices and things at their school. We wanted to make it easy for you to be like, this is what I've got, this is what I've got, this is what I've got. Okay, this is what I should use. So for example, you would select your robot, Hummingbird Bit, or if you've got the older version, that would be the Hummingbird Duo. Select your robot. You can select the device that you've got to program with. So I was just using an iPad, but let me show you what it's like if you've got a Chromebook at your school. And then there's a couple of different options. There's Make Code or there's Snap. There's a page, if you click this little eye right here, it would tell you a little bit about the programming languages, but I really like Make Code as a programming language. It's a lot like Scratch, and it's got a couple of really cool capabilities. So when you hit Get Started, it opens up these 4 tabs: Program, Build, Teach, and Resources. So if I wanted to learn how to program all the different things on my Hummingbird, well, you would do that and learn to do that in the Program tab. So we tried to make the learning here really modular for teachers, a lot like the teachers in Iowa who found themselves with a Hummingbird and maybe didn't know how to use it very well. So if you've got a Hummingbird in front of you, this site is perfect for you because this will teach you just great little chunks of how to use your Hummingbird. You don't have to spend 3 hours learning every little thing about it. You can just learn. You can do the setup module, which is 6 steps. And then you can go to single color LED and you can learn to do what I just showed you how to do. I really like in make code, in all of these, the second to last step, it always has a side-by-side of the code running next to the component working. And the very last step has a little challenge. How could you make your LED blink faster? So there's like a few great ways to use these video tutorials in your classroom. Number one, you could give your students this site and they could learn to program directly from our site, because these videos, although they do have text on the side here, you don't necessarily have to read it. We made it so that we show you exactly which blocks to drag out. If you're in MakeCode, we have screen caps where we show you exactly what to drag out. And we show you the side-by-side runtime here. So that's one way. You could use these tutorials to teach yourself how to program and then sort of direct instruction teach your whole class of students. Do whole class instruction. You could sit down and teach a kid just, you know, talking to them like that. Or another way is these coding cards down here. See this purple button that says coding cards? This is another way that you could learn to program too. So these coding cards, I'll show you the make code coding cards. On the front of the card, we show you how and where to plug in a component like a single LED. And on the back looks like this. We show you a little example of program and give you a little challenge to go with it. So your students could recreate that code that's on the card and then try the little challenge that's underneath. So that's another way that they could learn. So if you have internet access, if you have the ability for, you know, each group of 2 or 3 students to be online, you could have them learn directly from the video tutorials, or if you want to be a little bit more unplugged, they could use the coding cards instead to learn to program. So let me go back to here now. So that was the single color LED, but you don't have to start there. You could start with the position servo motor if you wanted to. You can start anywhere. We tried to make it really modular, so you could just get these little useful, like here's 6 or 7 steps on how to program this component. And we even show you a nice little project that you could do with just that component, with just a motor. You might recognize that from right back there. Keep it on our shelf, keep it close. It's a pretty cool little protractor. In talking about what's on our website though, all of those programming tutorials are just in that program page. On the build page, that's where we've got all kinds of tutorials and tips and tricks and ideas for what you could build with a Hummingbird. And this is where, after I show you this page, this is where I'm gonna hand the mic back to Jolie, because she is gonna tell us about some of the tools that came in your maker cart that would be great to build with your Hummingbird. So just to kind of talk you through what's on here, at the bottom, we have these things we call Hummingbird Hacks. So we have little like tips about like, okay, so you know how to wiggle a motor back and forth, or you know how to blink a light. Now I want to add a light to like a box. I want to make something out of it, like my owl in the background here with his eyes blinking. How do I mount an LED to a box? Well, cut an X in the box, feed the wires through, and then it makes this really nice cardboard mount here. Or, you know what, I want to do something like my hula dancer back here. She's wiggling her little grass skirt, but I don't want the motor to stick out forever. How could I get my motor to sit down in the box? So we've got a little building hack to show you how to cut a hole for your motor, sink the motor down in it, and now you've got a motor that's mounted much closer to your flat surface for your project. So those are some different building hacks that we have on the build page. We also have all of these cool, simple robots that will show you step by step how to make something like the little bot. I don't know if you recognize him, but he's also back here behind me. I made a little bot, and I made my little bot into Harry Potter because I can't help myself because I love Harry Potter. So you can make your little bot into whatever you want to make it into, but we'll show you the basics of how to do something like that. The tiny drummer is one of my other favorite ones. The concept here is so simple. He's just a piece of cardboard and a popsicle stick drumming on an upside down cup, making noise. But this, if you open it up and you say, all right, students, pick your favorite song and make this your own. So here's sort of the template for a flat character drumming on a cup, but like make this your own project. Make it a Queen song, make it Childish Gambino, like whatever. Every kid has a favorite song, so this can be a really great way to reach kids where they are and let them kind of riff on a theme like that. And for those of you who are ready for a little bit more advanced building, we have some great mechanisms on this page as well. So we have like the crank, the winch, the cable system. All of these just use basic craft supplies, popsicle sticks, little brass fasteners, cardboard, toilet paper tubes, stuff like that that you can find in your home, that you can find for free if you ask your kids to bring some stuff in. So they can make mechanisms like that. But something that we don't have on this page, but that Iowa educators who have gotten the STEM Scale-Up grant do have in their maker cabinets are some really cool maker tools like the Make Do and the 3 Ducks connectors. So I have those in our Google Doc as well, so you can kind of see what the Make Do's are and the 3 Ducks connectors are. But I'll turn it back over to Jolie so she can tell you a little bit more about what those are and how you might use them.
So thank you, Kelsey. So when we put together the list of materials to go into the Making STEM Connection Kit, we really wanted that to be like a resource closet for you. So you will find a lot of the tools and components that Kelsey is talking about to use to make these kind of things in your kit. We also wanted to give you things that your students could use in a variety of different ways, because what we want to do is teach them the basic components of how to code, how to get an outcome from a robot, but then we want them to solve their own problem and think in their own way of how to do that. So we wanted to provide you lots of tools that would allow for that. Some of those tools are the Make Do's. So you received this in your kit, and the Make Do tools allow you to cut cardboard and connect cardboard together using the screws and the screwdrivers. So you got a lot of these screws, some special screwdrivers and special cardboard cutting tools. So here's the screwdriver, and you can also 3D print connectors that work with, you can 3D print actually a bit to go with your cordless drill for your screws. And I've put that on our Facebook page, but you can also 3D print different L brackets at different angles to go along with it. What I want to show you today is how I used the Hummingbird materials with the 3 Ducks kit. So the 3 Ducks kit is new this year. It's a new piece that we put into the kit. And basically they are just little cardboard connectors, and they come at a variety of angles, and you also got a box full of all different cut pieces of cardboard. So here's what I did. I made a North Pole finder. So it's designed to look like a sled.
Yeah.
Okay. And what is inside of here is the Hummingbird and the battery pack, just like what Kelsey showed you. And then here is the Microbit right here. And here's a servo motor on the end. Okay, the rotational motor. And then there's a couple of lights here. So I'm going to turn it on. So I made a little opening back here, okay, to turn it on. And the idea is that it is going to help me to find the direction of north. So what I did is I coded, and this is a little hard to tilt and show you, but I coded so that these lights will show me how many degrees I am. I use the 360 degrees that the compass on the Microbit recognizes. And I told it that if I'm between 0 and 180 to turn this light blue, and if I'm between 180 and 360, 355, I put a little margin of error in there to turn this green, to turn this light green. And the idea is that if I can get them to both point at 0, which is north, they will turn red. Okay. So I did some, and I'll show you my screen. My husband is a surveyor and an engineer. And so he said, wouldn't it be cool if you could make your own survey tool? And I thought, why not make our own detector for the North Pole? I also set it up, and I'll show you the code. It's not that complicated. I also made it so that the Microbit right here will show me the letter of the direction that I'm pointing at.
Whoa.
Okay, so this tells me that I'm pointing east. And the servo motor that's moving right now is telling me what direction to move to point towards north. And if I go past north, it'll start going in the other direction. It'll start going counterclockwise to tell me to move back. So I have an indicator in the motor telling me how to find north. I have an indicator in the direction on the microbit, and then I have the indicator based on these lights. Okay, so it could be as simple as just the lights, but I wanted this to kind of look like a sleigh, right? So maybe somebody like Santa might be trying to find his way back to the North Pole. And this is all, this container is made with all of the pieces in the 3 ducks kit. So what I would like to do, if I can, is share my screen, and I'll show you the code that I wrote. Okay, so can you see my screen now?
I think, yes, we can. Mhm.
Okay, so I just want to show you really quick, and what Kelsey was telling you about the tutorials is so true. They are very easy, they go step by step, and I learned how to use the compass in connection with the servo motor by following those steps. And it showed me also how to calibrate the microbit, which is really important. You need to calibrate it so it understands the directions. And then what I did is I went in here and found the compass heading in my input options here. And then I went to my logic steps here and my if statements, so my coding, right? So if this happens, then do this. And then I came down to my Hummingbird options and added things like the tricolor LED and the position servo components. And I did some math, which was, I had to really think about this, but in here, I told it that if my compass heading, and I put the constraint of the compass heading being between 2 different angles, then turn the servo in this direction at this speed. If it's between these headings, then turn it in the opposite direction. Okay, so I just added these into those open windows in the code down here. And then I said, if I hit 0 to make them stop. So if I can get to north, the motor should stop. And that's how I know I'm pointing 0. Then if you scroll farther down, I did the same kind of statements, but I made new parameters. So I'm saying if my angle is a minimum of 5 and a maximum of 180, then turn the light blue. If not, so I did an else statement, then turn it red. And that's how I would know. Okay. Yeah. And then I did the same thing for the other part of the circle. So my 180 to 355 to turn it green. So that's on the other side of my sled to help me. And then down here, I use that LED screen or alignment, or I can't think of the word right now, but the
LED screen.
Yes, thank you.
Yeah, I got you.
To show, okay, so if my compass heading is 0, so now imagine the math. So your students are taking your 360-degree circle and thinking of it in terms of directions, which is how a compass works. And then they have to calculate, then what would be your cardinal directions? So north would then be 0. So I told it if it's heading 0 to put an N on that display, okay? If it's at 90, then that means it's pointing east. So imagine you could even get into, well, what is northeast and what is northeast? And they could go through and calculate that based on their angles and their degrees and add that component here. Yeah. So this may look complicated, but exactly what Kelsey is telling you, it is not. And I would not start kids with all of these components. Start them with exactly what Kelsey was saying. Start by just adding one piece. Just add a light and then find out, okay, what can I add to it? And they will naturally want to progress, just like they do with video games, and go to the next level. Okay, well, what else can I do with the light? And then when they have these basic skills, then what you can do is say, okay, well, let's go back to all the components we have in our kit. What's something you want to make? What's a problem you want to address? What is something that we want to look at maybe doing in a different way, or could solve it or make it better using all of those skills, right, that we just came up with? And even though this device, right here, isn't necessarily solving huge problems in the world, they can begin to understand how their ideas and simple components, right, put together can do something that they wanted to do, which is the whole process really of coding and robotics. So how do we make it do what we want it to do? And they might find a next step to this, right? So maybe this is something for if you get lost somewhere, how to find your direction, or how to point something out. So it can, it can definitely progress from there.
I so appreciate that project, Jolie, because you were saying like, oh, maybe this isn't solving like big world problems. Well, they're 8 or 10 or 14, like they're maybe not quite ready to solve world hunger yet, but like starting with what are you interested in? What is interesting to you as a learner and a maker and a builder? Let's solve that problem first. Let's build up your confidence so that if you're interested in how do I find north, hey, let's start there. Let's build that. I have a similar project that I wanted to show you guys. This guy right here, he's very funny to me. He makes me laugh. It's a little Oregon Trail robot. I have a couple different names for it. I call it the Go West Young Robot or the Westward Hobot. I don't think I'm supposed to say that one, but I like it. Or the You Died of Dysentery robot. That's my other favorite one. But it's a covered wagon, and let me show you what it does. When I turn it on, it also uses the compass. So this covered wagon will turn itself until it finds west, and then it will go west. So here is west. It will always find west, and it will go that way. So mine is only using 2 motors, and if I turn it the other way, it'll turn around until it finds west, or until it runs into my coffee cup. There we go, west. This one's only using 2 motors. Jolie's project had a lot more coding involved in it, actually, because she had multiple components. She had tricolor LEDs and a motor, and she was using the LED screen. This just used 2 motors. So part of the reason that we made those tutorials so modular, such like digestible little chunks, is that we wanted you to kind of remix it and mix and match it and make what you want to make with it. The thing that I really like about the 3-Dux connectors, and can you hold your project up again? I want to pin your video up so people can see it while we're talking about it, and just kind of twirl it around a little bit, Vanna White it. Yeah, beautiful. See those connectors? The thing that I love about those is I think they make it really easy to prototype with a Hummingbird, to make a little something around it. Because if we go back to, I'll just do a full screen on mine. If we go back to this, I had to hot glue on here, which you certainly can do. You can certainly hot glue it. It's not any trouble to do that. Where did I go? Lost my mouse. It's no problem to hot glue anything on there, but it does make it a little bit, if you don't want to have hot glue in your classroom or something, if you're working with younger students, or you don't want that, if that's just a little too much for your particular classroom, I think those 3-Dux connectors make it really easy to build something 3-dimensional, and to also to like prototype it. So if I were going to make this thing, maybe I would start by using some of those 3-Dux connectors to make an earlier version of it. And then once I had it working like I wanted it to, maybe then I really cement everything down with some hot glue to make the project that I see in my head, Cool. There was a really good question that somebody had asked. They asked how old should students be to do projects like this. So we recommend Hummingbird for 4th grade through 12th grade. And as far as like what projects should you do with different age grades, at different ages and different grades, that is a really awesome segue to the other 2 tabs that we haven't talked about, because we looked at program and build. And if we take a look at teach, this is a page that has over 60 different projects on it, most of them from classrooms around the world that teachers have actually taught in their classrooms. And you can even filter it by like, all right, I'm looking for like 4th grade through 8th grade. I kind of teach that age range. And I'm looking for like math and science projects. And it'll filter out so that you just see the projects that are pertinent to your interest there. So I think that's really cool. But if I unfilter everything here, these projects, if you kind of put your mouse over it, you'll see a quick description. So this one's called Robot Shakespeare. And if I look inside, inside of here, you'll see there are, I'm gonna mute it, videos of students' work. So in this particular project, what students did was they read Romeo and Juliet. They didn't have to, they got to. I'm an English teacher. They got to read Romeo and Juliet. And then their project was that each group got a different scene from the book. They had to record themselves reading the dialogue of that scene, and then they had to make a little like shoebox diorama of that scene and sync up the movements to the dialogue. And so you get some really ornate projects. This one coming up, they're reading a lot of dialogue right now, but then the nurse comes in, and then this project kind of just keeps going. It's got all kinds of cool things that happen with it. And I know kids are always saying, like, nothing happens in Shakespeare. Like, people die. There are sword fights. Like, there's a lot that happens. People enter and exit. Like, there's a lot going on, actually. They just talk in very long sentences in the meantime. But I love this project for bringing these scenes to life. But underneath, you can see we've got the teacher's objectives and learning goals, the standards that she aligned to, excuse me. And if you look at these standards for this particular project, they're actually ELA standards. So some of our projects are aligned to computer science standards, some are next generation science standards, some are math standards, but this one is actually ELA because she was very deeply and meaningfully teaching English to 8th graders, excuse me, with this project. And then underneath, she's got her lesson procedures. This is how she taught it. She's got some videos of her students doing their verbal assessments at the end. And then we always credit the teacher that we found these projects from. But just to look a little bit more in depth to showcase some of the projects that you can find on that page, I wanted to show you a couple of them. So this one here is a muscles and bones project that we got from a science teacher just outside Pittsburgh. I'm going to switch my camera over. There we go. Oh no, get out of the shot. Dysentery. Okay, come back. There we go. So this guy is demonstrating how muscles and bones work. So you can see the muscles are represented by the pipe cleaners, and the bones are represented. This is cardboard. I recreated this one. This is cardboard wrapped in masking tape that I drew some like really good bones on, if I do say so myself. But it's demonstrating how muscles move bones. So the thing that moves your elbow is not something happening at your elbow. It's your bicep and your tricep. So to bring your arm up, this shortens. To let your arm go down, your bicep lengthens and your tricep shortens. And so that's what this motor at the top is doing. So this is a science project. This is a biology project that would be appropriate for what grades do you study muscles and bones in? Sometimes it's middle school, sometimes it's elementary school. So this would be a really great science project. Let me show you another really great science project that I'm really proud of. Okay. So this one is an interactive map. Now this could be a science project. It could be a social studies project. It kind of depends what subject you would cover this in. There we go. This right here is an interactive map. So this is a map of monarch butterfly migration. And so you can see the different lights as they light up. They're actually different colors. The ones down in Mexico are red, the ones in the southeast United States are yellow, and the ones up in Canada are green. And so this shows, thank you, Matt. Matt does great things with lights. Isn't he great? Thanks, Matt. But you can see the different colors. They actually represent different generations, because something I learned in a conversation I was having with a friend and then confirmed on Wikipedia is that it actually takes 3 generations of butterflies to get from Mexico all the way up to Canada. The first generation makes it up to about northern Mexico. The second generation is born in about the southeastern United States. And then the third generation is the one that makes it all the way up. And then the 4th generation comes back. And I actually made this an interactive map as well by adding a dial to it. So let me show you my project with the dial. So this dial, if I zoom in on the dial a little bit here, you can see that it shows the different times of year: March, April, May, June, July. And then I've got red, green, and yellow to represent the different generations. So as I turn the dial around here and point to the different times of year, you can see about where the different butterflies are and about which generation is associated with that. So as I turn the dial around, it's an interactive map showing these migration patterns. I'm really proud of it. I really like that project. It's pretty cool. Thank you for turning that light down for me, Matt. All right, and I'll scooch this guy back over. And then I want to show you one other project, which is this guy. This is a beautiful little owl. I don't have a name for him yet. Maybe you guys can help me name him. But he's this cute little owl, and he's in a certain mode right now where he's just kind of looking around, and his eyes are kind of just blinking softly. But if I open up the side of his head in a very gentle and loving way, just push B, right?
Yes.
Yeah, there we go. Okay. So he's actually got a light sensor on the top of his head. You see that light sensor up there? It kind of looks like an LED, but it's the light sensor. So when I pet him, because he's part of our robot petting zoo, turn him that way so you can see him a little better. When I pet his head and block the light sensor, he comes to life and he does a little dance and he looks at you because he likes to be petted. Very good. I don't know why he's German all of a sudden, whatever. But anyway, this is another project that's on our website called the Robot Petting Zoo, where students get to pick an animal, whatever their favorite animal is, real, imaginary, extinct, whatever. I've had girls ask me, can I make a unicorn that farts rainbows? Like, of course you can. If you can engineer it, you can make it. Yes. This could also be an animal adaptations project where I had one where teachers made a green background underneath, and they made a little chameleon out of packing peanuts that when you were far away from a distance sensor, it was red and it wiggled around. And when you got close to the distance sensor, the chameleon turned green to blend in with the background, and it stopped wiggling and it just stood very still. So there's all kinds of different projects you can make. Anything, actually I'll keep him out here. He doesn't keep going off. Anything you can make with craft supplies, with the different supplies that are in your maker cabinet or that are in your maker space, whatever you've got in your school, all of those projects are possible. You can put lights and motors and sensors on them as well. We've taken a look at a couple different classroom projects. There's about 10 minutes left here. I'd love to hear, I have a couple like just follow-up questions for you guys. So if you go back to menti.com, I have another question that I'd love to ask you guys for us to engage in together. So if you go back to menti.com, let me do webinar closing, this one. Okay. So, and if you enter in these numbers, let me go back to this one. There we go. If you enter in 470376, those three numbers, I'd love to just see, this will have like a scrolling list here. What ideas do you have for how you could use a hummingbird in your classroom? I know Jolie was talking about a flag system that she had used. We have a link to a picture of that if you were interested in that. Or, oh, we're doing a, I want to have the kids do, bring to life a moving masterpiece, a piece of artwork. Or I'd love to have the kids, we're doing a Save the Bees project, and I'd love for them to make robot bees or to make funky little creatures. I'd love to just hear a couple of your ideas for how you could use a hummingbird in your classroom. And then I have one other question as well, but if any of you have questions as we're going through this, feel free to unmute yourselves and you can ask verbally or you can type them in the chat window as well. So I'll let some answers come in here, but if you have any questions about how to use a hummingbird, projects you could do, anything like that, you can unmute yourselves or type those in the chat window. I'm gonna put my map back up on the shelf while we start to think about projects we could do with a hummingbird.
Kelsey, this is Jolie. I just wanted to share the picture that that I provided to Kelsey that's on the syllabus for today is a teacher that was at one of the trainings this summer, and she had never used the Hummingbird materials before, and admittedly she was uncomfortable with coding and programming. This was at a training in Fort Dodge. And remember how for our trainings this summer we had the challenge of how do you prevent the devastating effects of severe floods? So her plan was to create a warning system using flags. So she created a sensor that would sense how high the water got, and then the flag would come up to say that the water was rising to a point. She did that all during the amount of time we had to work on that. If you all remember our trainings, she did that in that amount of time, never having any experience with the Hummingbird materials before that.
That's awesome. I honestly see so many teachers do like a lot of the teachers, so I teach teachers all around the world, right? I teach hundreds of teachers every year, a lot like you, Jolie, and some teachers come into the workshops that I do with this sort of like, yeah, I'm here to learn, I'm really excited, I don't know what's going on, but let's do it. Some teachers come in with like, I've used a lot of different tools, but I'm interested in this one. Some teachers, especially when I work with like a whole district, some teachers did not necessarily choose to be in the room with me. They were sort of voluntold to be at this training with me, and I get this sort of energy of like, no, this is gonna be too hard. I'm gonna do my time in class with you today. Not everybody chooses to be there, but even those teachers, by the end of it, I've got them blinking lights, moving motors, and doing something like a robot poetry project where they bring the imagery of a poem to life. Or something like a smart home project. I just did this one a couple weeks ago, where each group in the classroom, in my room, so each group of like 3 to 4 teachers picked a room in a smart home, and they had to design devices in that room that connected to devices in other rooms to wake somebody up and get them through their morning routine and get them out the door. So like when the alarm clock went off, the coffee pot would start, and they were using radio function to do that. And I had them doing that in about a 5-hour training. It was really quick. And they learned lights, motors, sensors, and radio even in that 5-hour training. So you can really do a lot in a short amount of time. So we've got a couple of cool, I guess I can look at my screen here. This person wants to use a motor to rotate a cardboard circle and run the Ozobot. There we go, cool. So you're gonna get a Hummingbird to interact with another robot like an Ozobot. That's a cool idea. This one is interested in helping her beginner coders see their code in action. Yeah, I think that's one of the biggest things that I see Hummingbird do, that I saw with my girls in particular. Because to be honest, the first thing I tried to do with robotics with my girls, and these were inner city Pittsburgh girls, primarily African-American, low socioeconomic status, from the school up the hill from me. And when I said, all right, girls, we were going to use Lego Mindstorms, and they were the kinds that became bugs. And I was like, all right, girls, on Monday, I'll see you at the after school program. We're going to be coding robot bugs. And my girls were like, like, they were not into that at all. And one of them broke my heart by asking, how long are you going to be doing this for? I will come back to the club when you're done. And I was like, oh, no, just kidding. We're going to make glitter slime. Please come back to the program. So anyway, I like rethought my curriculum. And then the way that I presented Hummingbird was I didn't start with robotics, because as I learned later, they just didn't see themselves in that. So when I brought Hummingbird in, I said, all right, girls, who's ready to make cardboard animals? And they were like, yeah. Who's ready to make a move? Yeah. Well, we can do that with coding and robotics. And they were like, okay, Miss Kelsey, but just okay. Like, but that was the side door, right? And then I got my girls who, in particular, there was this one girl who was, she was struggling in school. I asked the teachers, like, which should I put these girls in my program? Like, I get 50 applications for 25 spots in my program. It was a really great program. And I would go and I'd ask teachers their opinions. And this girl, they were like, no, don't put her in your after school club. She is trouble. She is disruptive. And truth be told, she was very disruptive in my after school program, but I kept her in because she was the kid that needed to be there, right? And when she was doing this, she decided she was going to make a rabbit. It was her friend's rabbit. They were all in a group together. I forget the rabbit's name, but it was a fluffy white rabbit. And the thing they wanted to do was they wanted to put a light sensor on its head, just like the owl, and they wanted it to hop, which is like kind of a mechanically challenging thing to do. But I got these girls using variables and algebra to program the motors to like slow down and then speed up, because it had those little popsicle stick feet. And this girl who struggled the most to pay attention was so focused because this was a rabbit she knew. This was something she knew. So when you're saying you're really interested in helping your beginning coders see their code in action, seeing it in action with art supplies, craft supplies, things they're familiar with, I think is really, really helpful. So I'm just looking at some other, if anybody's got any other questions on
Kelsey, I've got a question, please.
Sure, yeah.
This is Deb, and I'm wondering about the numbers of students that you put in teams or groups to do your projects. And does it vary from younger kids, smaller groups, to larger groups and older kids? Or tell us some of your theories or thoughts on that, please.
Yeah, that's a great question. So for me, it's more about the complexity of the project. So if I were going to do something simple, like I've got one under here. if I were gonna make just a tiny drummer, I'd maybe put 2 kids in a group together. So I always recommend having at least 2 kids in a group together, because research tells us that kids learn programming better when they have somebody to talk to about it, because they're not only looking at the screen and going, wait, what block was I supposed to use? They turn to their partner and they say, wait, what block were we supposed to use? And they talk about what that block was, and they do it together. So at least 2 kids in a group. If I were going to be making something more complex, like this owl back here that's got a couple of motors, a couple of lights, maybe a couple sensors, if I were going to be doing something extra complicated, like all the lights that are on that map up there, I'd put 3 or 4 or even 5 kids in a group, depending on the 2 factors for me are how complex is the project and what are your time constraints. If you have a shorter amount of time, I put more kids in a group, because we got to go. We got to get stuff done. We need many hands to make light work here. So when I do my smart home project, when each group does a room, I put 4 or 5 teachers in a group to make that room that goes in the smart home. So anywhere from 2 to 5 students. It kind of, again, depends on the complexity of the project you want to do and your time constraints. Those are the 2 factors that I consider most. That was a really good question, Deb.
And then one other related thing, because I'm part of the Governor's Council people that work with Lee. So, and I gets to do the kits. And I've got people that I think are going to have the old Hummingbird and the new. So how much difference is there between, and how do you recommend we work, other than, you know, getting everybody in contact with Jolie? That's our first strategy. But
yeah, so the old Hummingbird.
Is there like a document that has a sheet, a comparison sheet or something?
Yeah, there is a document like that. And let me just show you briefly. This is my travel robot case. I travel with my robots in a makeup case to help keep things organized. Traveling robot lady life. But just to show you the difference between these 2 boards. Everything you can do with the old Hummingbird, you can do with the new Hummingbird. And the new Hummingbird, yeah, it does more stuff. It's cheaper, it's better packaged, it's got better learning materials. But there are some teachers that have this older version. So this one's the new one, this one's the old one. So if you've got the old one, you can continue to use it. If teachers are already using it, they can continue to use it just how they do. We're going to continue to support that with the programming languages that it works with, all of that. We're going to continue to support that forevermore. But if they want to upgrade their Hummingbird Duos to be able to do what the new Hummingbird Bits can do, it depends what they want to do with it, how they would upgrade it. And there is a sheet on our website that shows you a comparison here, and it shows you, like, if you want to, for example, if you want to use your Duo with the Microbit, we have an adapter, goes like this. It just snaps onto the bottom of your Duo kit like this. And that way you can plug a microbit in and use all those microbit functions, like the accelerometer and the compass and the radio function. So if you want to use the microbit functions, there's a way to do that. If you want to use the Bluetooth function, so the Duo as it is can only be used with a laptop or Chromebook, and it has to stay plugged in the whole time. It was the best thing out there about 8 years ago, 10 years ago when it came out, but this thing's the best thing out there. Anyway, if you want to use it with Bluetooth, you just get this Bluetooth adapter that also snaps onto the bottom. Unfortunately, they are 2 different adapters that do 2 different things. So if you want it to do the make code and the microbit stuff, you would get this adapter, and it comes in a little bundle with the adapter, the microbit, and a battery pack for about 30 bucks. Or you can get the Bluetooth adapter and a battery pack for about 30 bucks. So there's 2 different bundles that you could get. You can also get those separate. So it depends on what you want to do, but you can certainly upgrade your Duo to work. Like, if we recommend generally that you keep your Duos and your bits segregated. So if you have a classroom set of Duos, you keep those as a classroom set of Duos and you use those all together. And if you have a classroom set of bits, that you keep those as a classroom set of bits. But if you need to kind of mix and match them a little bit, you can, and you can upgrade your Duos to do everything that your bit can do. Does that answer that question? Great. Any other questions that people have? Yeah, so Matt Chilbert in the chat window, he just dropped in a couple of links about the different adapters for the Duo, so you can check those out on our web store and whatnot. Yeah. So with it's just a little bit past 6:30. So I wanted to just end by saying, if there's any questions that you guys have, I put our contact information, both for me and Jolie, I put that in the Google Doc. But if you're interested, we have a bunch of different ways to do professional development. And I know Jolie does this in Iowa. She does a lot of in-person professional development, and she does webinars and things too. We're going to be doing another webinar in just a couple of weeks that's going to focus on Duo users. So if you, Deb, or if anybody knows these Duo users and if they have these Duos in their classroom, we're going to be doing a webinar just focused on the Duo and the different adapters and what you can do with your Duo just as it is on December 10th, I think. Is that right, Jolie? Yeah, that's right. But if you have any questions for me about, we have some self-paced video courses that are going to be free, that we're working on filming them in our studio right now. But I'm really excited about those. They help teachers go through what we've done. They basically take an entire 6-hour full day workshop and smush it down into an hour's worth of videos, that there's like little individual videos, and you can watch one. There's a little challenge at the end. You can try it, and we talk you through everything that's on the website. If you're interested in doing some live stream learning with us through our space here, we can schedule that for your school, your whole district. Your teachers can Zoom in from wherever school they're in, and we can all learn Hummingbird together, or on-site workshops. I mentioned I'm from Iowa. My mom still lives in Des Moines, over in West Des Moines, so you can always bring me home to, to come do a workshop at your school too. Or Jolie, I'm sure, is interested in doing those as well. So that contact information for us is in our Google Doc here. So if you have any questions about anything, please be sure to ask me or Jolie. Jolie is such a pleasure to work with. She does really great work at the Science Center. They do really innovative things there. So I feel very honored that we got to partner together for tonight's webinar, and we'll get to do another one in just a couple weeks. So if anybody else has any questions, I'll hang out for the next few minutes. You can drop those in the chat window or chat via unmute yourself like Deb did and ask any questions. Thank you all so much for joining us. I'll also be sending a recording of this out. So if you want to show this to anybody, you can share that recording with anybody that you want to. So you're going to get to see your faces and all of my mistakes all over again. Just kidding. I never make mistakes. Thank you all so much for joining us tonight. This was really fun.
Thank you.
Thank you, Sarah. It was good to have you in our presence. Bye, Sarah.
Thanks, Jolie, for helping get this coordinated. This was really great. And I had some private chatting with a couple of my people from our region.
Great.
So we'll talk more, and I will talk it up tomorrow morning at our team meeting.
Awesome.
Good.
Hey,
Good. Thank you so much, Deb.
Deb,
Yeah, great.
I have a weird question for you, Deb.
Certainly.
I went to
One.
school with a kid named Ben Frazee. Any relation of yours?
Well, there's a Ben Frazee who's my nephew, but he's just a freshman in college, so.
Nope, wouldn't be him. All right.
No.
Gotta ask. Gotta ask.
It's a story about these three great big heavyset gentlemen that immigrated from Europe and came to New Jersey, and I just got it when I married in. So
Yeah. I married into Derringer. My maiden name was not any fun at all. So
yeah. Mm-hmm. So I have been the manager partner with Jolie and Renee since the project started.
Wonderful.
So I follow it really closely, and we use it really significantly in our region. So I was really glad to see so many of our folks on. I will talk it up, and I hope we get some of the 5 other managers on too to get some information. So
it was really, I mean, like I came to Iowa in October for the iTech conference.
Uh-huh.
And I just met so many teachers who have benefited from this program, and they're so grateful for it. The one thing I heard a lot was people would come up to my booth or see me in my BirdBrain shirt or whatever and just be like, "Oh, hummingbirds, I have those. How do you use them?" And I'm just like, "Yeah, exactly. Mm-hmm. Yes." So it's my goal actually to hopefully partner with some of the AEAs, both the 9 physical AEAs and the online AEA, and maybe also like Ren at the Department of Education, and to talk with them to maybe put together like a course for credit in the spring that teachers could go through, like an online live course like this that they could go through to get some credits or certifications or anything like that. Just extra training for those teachers who already have hummingbirds and just want to know more, like what we shared today, how to use it.
So I too, in the early part of my career, I'm now officially retired. And anyway, a long time ago, I taught in ELA as well. And the joke that I share with my educators when I go out and we start talking about this is about my non-gerund Southwest males who hated Romeo and Juliet and West Side Story. So that's why I so loved your deal, because now I've got, you know, proof for, I mean, and there's a lot of Iowa teachers that don't know what a gerund is. So once we talk about that, then we're good. But the point of that whole humorous exercise is that this type of stuff can be used across the spectrum. Coding is everything. It's not just computer science. So, I mean, and this is the message that Jolie and Patrick and, you know, all the people that do the training try and deliver. Yeah. So I really like all of the support that you showed on your website materials. I have not been to the BirdBrain website and gone through it, but I will now definitely do that and recommend it. And I know of my folks that were on today, I'm sure they will do the same, because the folks I had on are good learner people.
That's awesome. Yeah, we've revamped that website a lot in the past 12 months and really tried to make it a place where, like, start at the portal. So there's a big button that says get started. So start at that portal, select whatever you have or whatever you think you might have, and then it opens up all of these resources it was really designed for those people who, like, have a kit in front of them and they went to a training like 3 months ago, but they haven't picked it up again, or they never quite got, and it's just like, wait, what do I do with this? So it's really designed to help teachers get started implementing lights, motors, sensors, coding, computer science in a meaningful way in whatever subject they're in, you know?
Yeah. And I watched the participant number at the bottom really close, Jolie, because I know you were busy with 21. I thought that was really good. So
yeah, especially because we put this together like a week and a half ago. Like,
no doubt. That's how life is good. Okay, I will get off and let y'all go. Thanks, Jolie. We'll talk soon. I need to order a couple more kits. So,
okay. That sounds great. I'll be talking to Kelsey then.
Yeah. Okay. Talk to you later. Okay. Bye.
Okay, thank you
so much, everybody. Bye-bye.
Hey,
Bye.
before you hang up,
Yeah.
Beth had a question about the Finch too.
Sure. Beth had a question about the Finch 2. She has a Finch robot at the public library. Oh, yeah. Let me show you the Finch 2. I got one right here. Look at this puppy. This guy's the brand new Finch 2. And you're still on. Great. Okay. So this guy's the brand new Finch 2. I'll put it like this so you can see him a little better. So we made a bunch of, I won't even call them upgrades. Like it's completely redesigned from the Finch 1. So this guy, what I have here is actually just a 3D printed model. So the actual ones will look a little nicer than this one. But we've completely redesigned a bunch of things about it. You'll notice this guy has a Microbit as well now. So it's got all those Microbit functions, the buttons, the LED screen, the compass, the accelerometer, the radio, all that stuff. It's also got, it has a light in the nose, just like it used to. It's also got lights back here in the tail. And you'll notice this hole in the middle. It used to be that you could like tape a marker onto the back if you wanted to, but now you can put a Crayola marker right there in the middle and you can draw with it. So let me show you. Oh, you're good. So I just wanted to show you what it's like to program with this guy. Close. Let me show you what that looks like. So if I turn my Finch on, you can see those other lights light up. I can connect to it now. This one is called the Energetic Gray Beaver. Very good. All right. So if I want to program my robot to do stuff, let me do that. Oh, I don't have the Finch blocks on this one. Shoot. I do have them on my, right here. I have them on this one. No, but I have them on here. It just doesn't show up quite as well on the thing. There we go. So you can program your Finch with your laptop, your Chromebook, your iPad, your Kindle, whatever you've got. Same as the new Hummingbird. You can program, the Finch is really flexible with all of that. But I think one of the biggest pieces of feedback that we heard was that teachers just hated that cord. It really gets in the way and can affect how the Finch moves and everything. So you'll notice this guy is cordless, so it can do Bluetooth. You can plug it in and program it with that USB cord, and then you can download the code onto it, unplug it, and then it can go be a little autonomous robot, kind of rolling around like a little Roomba robot. But you can also program it with tablet, iPad, smartphone, and whatnot. So I'm going to show you, I'm going to show you actually, I'm going to start with Finch blocks. So it can work with block-based coding like Scratch, Snap, Bird blocks, which is what I showed you before. But also, I think the biggest innovation as far as programming goes is it can work with icon-based programming. So icon-based programming, if I zoom in on this a little bit, you can see these icons are way simpler even than blocks. So if I connect to my dude, don't mean to, this could be a lady finch, I'm not sure. Now I'm on a Kindle here, so the Bluetooth isn't as good, so I might be struggling a little bit. So I'll just show you what this programming looks like. But I can drag out blocks like this, so I don't even have to be able to read. This is for pre-readers to be able to do. And I can drag out some blocks for the nose and the tail, and for some musical notes. Very good. Let me try one more time to see if I can get that to show up. Because then when you run that program, when you drag those blocks out and run the program, it will like show you which icon is running the program at the moment. So if I hit the green block, it won't do anything because it's not connected. But this would glow green, then this would glow green as the finch does each of these steps. But it's also a leveled program, so you can get up to level 2, and now you can control how far you want the finch to go, not 10 centimeters, 20 centimeters. And how much do I want the finch to turn? So right now it's at 90 degrees, but watch this little icon here. I can make it turn all the way around 180 degrees, and we're starting to build that angle knowledge. So this programming language makes the Finch 2 a pre-K, kindergarten, all the way up to AP computer science tool, because you can start with something like Finch blocks with pre-readers, help them level up through early elementary school, switch over to block-based coding like Bird blocks or Snap or Make code, and then when they're ready in middle school or high school, they can switch to Java or Python and be coding at that level as well. So this, you could have a classroom set of these, or a couple of them for your district, like one for each school, and the kindergarten teacher can use them for a couple weeks, and then the AP computer science teacher can use them for her, end of year assessment or whatever, and she can give them a coding challenge to do with that. And so I'm currently in the process of writing all the learning materials to go with Finch as the PD coordinator. That's part of my thing. So I'm making all kinds of different activities to go with it. Things like Finch jousting, where you've got to engineer a way to get Finch to knock a ball off of a cup, or making a Finch rover, where as you tilt the tablet, you can make your Finch into a little remote control car or remote control rover. So, I mean, it's got a lot of the same things that it had before. It has a, oops, let me go back to here. It's got a distance sensor right here. It's got light sensors embedded in it, LEDs. It's also got a line following sensor down here. You can put a marker in it there. Plus it's got all those sensors that come in the Microbit. So it's a super innovative tool. Right now, it's only available for pre-order. It's gonna start shipping in the spring. So you can pre-order them right now, and we'll kind of do first come, first served as far as like when we ship those out. But yeah, that's our Finch 2. It's really, really cool, and it really solves a lot of problems that teachers had just on the ground with Finch 1, and it does more things than just about any other tool out there in a really innovative way. Awesome. Well, thank you so much, Beth. Thanks for asking about Finch 2. We're really proud of it. So I wanted to focus on Hummingbird for this website, or with this webinar, but thank you so much. All right, I'm going to go ahead and sign off for the evening. All right, bye everybody.